The next topic we want to discuss will be aggregation versus composition. Let's take a look at this running example over here for us to define the terminology. It will help us. So we want to define what a container is and also what a containee is. So these two terms. And let's assume we got this particular object structure already exists at the runtime. In the next part of the module, I will actually show you how to build this object structure from scratch. For now, we simply assume it's there. So there are three kinds of objects we have to consider. We got students, we got courses, and also we got faculty members as the instructors for the course. So let's see quickly the relationship between the objects. A student, for example, Jim, he actually has an ID, well, simply the Jim. And also he is taking courses, which is simply an array. So we are talking about the programming pattern that was reviewed in the first 2 weeks. And then Jim currently is only taking two courses. So one of them is 2030, and the other one of them is actually 3311, right? That's how we actually can follow the links of the objects. And what about the courses? Let's say each course has its title, for example, Advanced OOP, the current course, or it can be maybe software design for 3311. And then each course has a single instructor, the prof. Okay, so for example, 2030 is now being taught by Jackie, and also 3311 is currently now being taught by Jonathan, right? It's easy to navigate once you visualize it. Finally, we got another kinds of objects which will be just faculty members, the instructors. For example, you can see every faculty member, they have their name, Jackie versus Jonathan, and also the list of courses they teach. I simply say TE, standing for teaching. So for Jackie, currently he's only teaching one course, which will be just 2030. And for Jonathan, he also only teaching one course, which will be 3311. Of course, in general, the number of courses taught by a faculty can be maybe up to 3 or 4, but for now, it's just one for simplicity. Okay, so understanding this particular object structure, let's now define the terms between container versus containee, and then we will revisit back to this object structure. Let's now go back to the slides. Let's now go over. So what is really a container? A container is simply an object that contains others. For example, you can see the course contains a faculty object over here as its prof. A student contain a course object as one of its enrolled courses. And also a faculty also contain a course as one of their teaching duties, right? So now the contain, it depends on how many objects you can really contain. For example, here, when you say course, it only contains a single object being its instructor. On the other hand, for students and also for faculty, they actually contain multiple course objects as their, for example, you can see student here, it contains multiple, 1 and 2, more than one, multiple courses as their enrollments. Versus a faculty may contain more than one courses as their teaching duties, right? Hopefully you can see that. And containee is simply the symmetric notion. So an object that's contained within another. Let's now take a look over here. Okay, let's talk about just a student. Let's talk about a course case. That's kind of easier. So let's say we talk about the course over here, and a course actually contain a single faculty member as its instructor. So let's take a look. So over here, so now I'll simply draw this link. So a course simply contain a faculty member as its prof. So as far as this particular relation is concerned, we say course is the container. And symmetrically, the faculty here is a containee. It's being contained. Okay, so this one, hopefully you're fine. Let's take a look at another one. And let's say, as far as this one is concerned, each student may contain multiple courses as their enrollments. For example, you can see Jim over here contains one course over here, and also contain another course over here. Let's now draw using a different color. Let me now maybe use pink. You can see for this particular student, it contains one course, and it contains just another course over here. Okay, so let's now color that, and then I'll write it down as well. You can see a And objects can be the container and containee simultaneously, depending on which relation you're talking about, right? Simply analogously, remember a method can be the caller and callee simultaneously, as we talked about before, right? It's kind of analogous. It's similar. Okay, so now this one here will be the container. Let me write it down. So this will be the container. And also these two courses over here, these two courses objects here, so they are part of the enrollment for gym. So these are the containees. All right, hopefully so far you're okay. And as an exercise for you, here we say that each faculty member, for example Jackie, actually contains one single course as their teaching duties. Of course, in general, it can be more than one course as their teaching duty. In that case, who will be the container and who will be the containee? I'll leave that as an exercise for you. You can do the similar annotation like what I did over here between the students and then the courses. Okay, I'll leave that leave for you to do. All right, and pretty much whatever that's in the slide, I have already sent many of them. Let's take a look. So each course has a faculty member as its instructor. Okay, and then so container will be course and containee will be faculty. Very quickly, each course contains a faculty member as their instructor, the prof. Right, that's the attribute name. So this will be the container. This will be the containee. Right, and then the number of containees may be a single one, like a single instructor for the course, or it can be multiple ones. For example, you can each student is enrolled in a list of courses. So in this case, a list of courses is the list of containees. And also each faculty member teaches a list of courses. In this case, course is also the list of containees. Okay, you can see container will be students and faculty, similar to what we did before. You can see student here is a container, which contains more than one courses as its containees, right? It can be multiple. Sometimes maybe a special case like one, but in general, it can be more than one. Or in the special case, it can be just zero, like an empty array at the moment. Okay? It depends on how you implement it. Okay, so let's now go over some facts about the container and containee. Let's say here, so we say EECS2030 taken by Jin and also taught by Tom. So what we are saying is, you can see here, this is actually one of the course that's actually taken by Jim. And also, this is also one of the courses that's actually taught by Jackie. You can see the same course that we are talking about over here, right? So that means the containee may be shared among the container. Okay, that's really important to actually notice. So I'm just going to highlight this particular object over here. Let me just use a green color over here. So this one here, okay, you can see here we got one over here, and also we got another color over here, right? For this particular point, I want to just say it here. Okay, let me just put it here. A containee may be shared, or you can say contained, by multiple containers. So here, the really important concept is about sharing. Okay, a single containee may be shared by multiple containers. Okay, that's very important to see. Of course, you can also see that another example would be this particular course over here. You can see this course is shared by which two objects? It's shared by Jin, is also enrolled in that course, and Jonathan is actually also teaching that course. So that course is also shared by two containers. In this case, it will be Jonathan objects and also Jim objects, right? Similar. Okay, let's see. And yeah, so containees may be shared by different instances of containers. We just illustrated it. Another one, let's say when 2030 is finished, maybe after the current fall semester, so Jim and Jackie may still exist. So what I meant was, let's say around December 25th, when everybody is ready for the holiday, the registrar office may decide to destroy this course objects over here, just to save space, to also at the same time to mark some official end or termination for the course. So now think about this. This course, as far as Jackie is concerned, Jackie is containee because the course contains a prof. That will be Jackie, right? And this course, as far as Jim is concerned, Jim is actually its container because Jim is enrolled in this particular course, right? So you can see the course now being destroyed. Will its container and also containee both be destroyed as well? The answer is no, because when the course is destroyed, what about its containee? In this case, Jackie better still exist in at York just to continue with his teaching career, and also for when the 2030 is destroyed, should Jim still exist at York? Of course, he better do just to continue with his degree. So that's about the nature of container and containee in the case of aggregation, which means everything will just be somehow shared. But when things get destroyed, you don't have to have any cascading effects to destroy everything else. You don't need to. But that will be the case for composition, as we'll see. Let me write down this point, which is very important. Okay. Let's now try to do the following. Okay, let me remind you very quickly over here. So let me use some purple color over here. So now we talk about this particular course over here, right? This course, and then as far as the prof is concerned, it is the containee, and also as far as the student Jim is concerned, it is the container. Okay, like this way. Okay. Okay, I better just not highlight it. It might be a little bit too messy, but let me just now write it down. Okay, so I'll simply go from this course object over here. Okay, when the container, so the container over here is with respect to the faculty. Right, the faculty there specifically will be Jackie objects. It says containee. When the container or the containee, and over here, this containee is with respect to the student objects because Jim actually contains different courses object. In this case, the 2030 objects with respect to students. Right, I'm just trying to write down precisely. Whenever you talk about container or containee, it should be relative to the other end. With respect to students, is destroyed. The other end. In this case, the faculty or the students should not be destroyed. Should still exist. Okay, hopefully that's very clear to you. So when the container or the containee is destroyed, the other end should still exist. Okay, that's really important to note. Okay, let's now go back. So these are the 2 points you really want to make sure you understand about these two. One is about sharing. The other one is about when you delete one of the sharing links, should other things should still exist? The answer is yes. Okay. Okay, containees may exist independently without their containers, right? If you destroy either container or containee, the other end should still exist. All right. So okay. So this is so-called aggregation, which we'll talk about first. Once we so we are just now just clarifying the terminology. We'll see exactly how you can build sharing links for aggregation in a moment in the next part of the module. Let's now talk about another example to illustrate composition. Okay. In a file system, each directory contains a list of files. Let me use the following example, right? I just created some folder on my desktop. If you take a look, I got a folder called D over here. Inside D, I got 2 directories, D1 and D2. Under D1, I got F1, F2. And also under D2, I got F1 and F2 as well. You can see even though the F1 and F1 over here have the same name, but they're under a different context of the parent directory. That's quite obvious, right? Okay, let's now. So file system, in this case, is a very typical example for composition. And in some way, you can see we don't really share any files. You can see this F1 here only is actually owned, we say. It's being exclusively owned by its directory over here. So F1, this file here, is not really shared by D2 over here. It's not the case. So that's a very typical indication about you should really use composition when there's no sharing. So container in this case will be directory which contains a list of files, which will be the containees. Okay. and then each file has exactly one parent directory. Okay, so that means containee may be owned by only one container. If you take a look at that, you can think about D1 is owned by D, which is the top directory that we have, right? Over here, the top one, okay? And also D2 also has one parent directory, which is D over here. F1 is only owned by D1. F1 is not owned by D2, right? Only one, okay? That's ownership is really important to explain composition. And deleting a directory also deletes the files it contains. For example, if I go into D, if I simply try to delete, right? If I try to delete D1, so let me now move that to trash. For example, you can see I also delete whatever files that's owned by D1. So I cannot, they don't exist anymore. So really contrast this case with if I try to delete, let's say the course, which is a container of the faculty Jackie. So when we delete course, we don't delete Jackie from York. We don't do that, right? It's simply not the right thing to do. So whether to use aggregation in this case or use composition in this case, it's really up to what's really happening in the real life. You have to try to mimic or try to model what's really happening in the reality. Okay, so there's something, sometimes there's really no right or wrong about whether composition or aggregation should be used. Either no sharing for composition or with sharing with aggregation. Which one to use depends on the situation you want to judge. Okay, all right. So containees may coexist, may not. Actually, they should really coexist. That's exactly what I meant. Coexist simply means if you delete one, the other one should really be gone, right? So if you delete the containers, you should also delete the containees. On the other hand, of course, it's kind of asymmetric. It's not symmetric. If I only delete F1, do I need to delete F2? I don't need to, right? So in the case of composition, you have to think about if the container is actually deleted, the containees that's contained inside should be deleted as well, but not the other way around. If you delete the containee over here, like I'm deleting, for example, I'm deleting D2, which is contained by D. I don't really delete D at the same time. So whenever you got a little bit confusion about which one should be kept, think about the file system folder analogy I'm trying to make over here, right? That will help you.